We continue our discussion on integrals involving powers of tangent, cotangent, secant, and cosecant. For case 3, we have integrals of the form tangent to the mu, secant to the nu du, or cotangent to the mu, cosecant to the nu du, where n is a positive even integer. In other words, the power of tangent or cotangent could be any rational exponent m. It could be an integral exponent, a negative exponent, or a rational exponent. So the rule is to factor secant squared u, or in the case of the power of cosecant, we factor cosecant squared u. And then we express all the remaining factors as powers of tangent or cotangent. Alright? So we apply the identities. 1 plus tangent squared u equal to secant squared u, and 1 plus cotangent squared u equal to cosecant squared u. Alright? So what we do is, after factoring secant squared, express the remaining factors in terms of tangent, because we know that the derivative of tangent is secant squared u. No? So any power of tangent together with secant squared u du, we can apply the power formula. In the same manner, if we have cosecant squared u and associated with it is the power of cotangent, we can apply the power formula, as we know that the derivative of cotangent is negative cosecant squared u. Right? So for our first example, we evaluate tangent cube 2x and secant to the fourth 2x dx. We examine the power of secant, which is 4, positive even integer. So we are going to factor secant squared. We rewrite tangent cube 2x, and secant to the fourth is written as secant squared 2x times secant squared 2x dx. So we shall preserve secant squared 2x dx because we know that that is the derivative of tangent. No? So what we are going to do is we will replace secant squared 2x by 1 plus tangent squared 2x. Then we distribute tangent cube 2x to 1 plus tangent squared 2x. So that becomes tangent cube times 1 is tangent cube 2x secant squared 2x dx. So we're now writing this as two integrals. So plus tangent cube times tangent squared gives us tangent to the fifth 2x and secant squared 2x dx. So for both integrals, we can apply the power formula. No? So we apply the power formula for both integrals, where your u is tangent 2x and du is secant squared 2x times 2 dx. So the first integral, we need to complete our du, so we introduce 2 and then we multiply it by its reciprocal 1/2. Apply the power formula, that will be 1/2 tangent raised to 4 2x all over 4. We do the same thing for the second integral. We complete the differential by introducing 2 and multiplying it by 1/2. So that becomes 1/2, and power formula, tangent raised to 5 becomes tangent raised to 6 2x all over 6 plus c. We can write our final answer as 1 over 8 tangent raised to 4 2x plus 1 over 12 tangent raised to 6 2x plus c. Okay, so we take on another example. We try another one. Say the integral of cosecant to the fourth 3t dt all over cotangent cube 3t. So we examine the power of cosecant, which is again 4, positive even integer. So what we do is we factor cosecant squared. And we rewrite 1 over cotangent cube 3t as cotangent raised to negative 3 3t. We bring up our cotangent cube 3t, so we will have a negative exponent of negative 3. And cosecant to the fourth will be split into cosecant squared 3t cosecant squared 3t dt. And we know that cosecant 3t dt, cosecant squared 3t dt is the differential of cotangent. So we shall now replace cosecant squared by 1 plus cotangent squared 3t. Just like what we have done earlier, we will distribute cotangent to the negative 3t and split this into two integrals. So cotangent to the negative 3 3t times 1 is cotangent to the negative 3 3t cosecant squared 3t dt plus cotangent to the negative 3 times cotangent squared will give us cotangent to the negative 1 3t cosecant squared 3t dt. Now we are ready to apply once again the power formula for both integrals. So we take on cotangent 3t as our u, and our du is negative cosecant squared 3t times 3 dt. So in the first integral, it lacks negative 3. We introduce the reciprocal of negative 1/3. Alright? So it will be negative 1/3, and cotangent to the negative 3 will become cotangent to the negative 2, 3t all over negative 2. For the second integral, it lacks the same constant negative 3. Again, we multiply it by negative 1/3. So it will be negative 1/3, and cotangent to the negative 1. Sorry, it's not the power formula. No? So it's not the power formula. Why? Because the exponent is negative 1. It is negative 1. So what we have to apply here is the integral of du all over u. Okay? So we know that the integral of du over u is ln, or the natural logarithm of the absolute value of cotangent 3t plus c. We now write our final answer as negative 1/3 times negative 1/2 is positive 1 over 6. And cotangent to the negative 2 is 1 over cotangent squared. No? That is 1 over cotangent squared. And what is 1 over cotangent? That is equivalent to tangent squared of 3t minus 1/3 ln of the absolute value of cotangent 3t plus c. So that is our final answer.